So it's a great pleasure for us to welcome Allcott, who is associate professor at New York University. He is also co-editor of the Journal of Public Economics. So Hunt holds a PhD in public policy from Harvard University. He's also engineer from Stanford. I mean, many of you should know Hunt Allcott's work. He has, work a lot on the energy efficiency gap, on energy nudges, on program evaluation, on resources, oil extraction, and so on. He has published in very good top journal like American Economic Review, Quarterly Journal of Economics, Review of Economics and Statistics, Journal of Public Economics, and Resource and Energy Economics, which is a good journal. Science, Journal of Economic Perspectives. So some of you may be disappointed that Hunt was not around the full 2 days, but if you have to blame someone, you should blame me, because he asked me some advices to spend the weekend, and my advices were, I think, too good, so he decided to extend the weekend up to now. But we are very grateful that he's around. He sent me the slide, and the slides are very nice as well. So enjoy it.
I'm humbled for a number of reasons. Thank you for having me here today. I'm humbled for a number of reasons. One is that, yes, I have indeed taken probably my first vacation in a very long time, and probably my only vacation for another very long time, but it was nice. And I'm excited to be here, and I'm excited to talk with all you guys afterwards as well. I'm excited to hear what you guys have been working on, if anybody wants to chat after the talk. And I'm also humbled for a second reason, which is that I'm in a room with people who, with I think a number of people who are very distinguished, and it's great to be here and great to be able to speak with you guys. So I want to give a talk which I've called Evaluating Energy Efficiency. This is builds on work. I'm going to talk about some of my own papers. I'm going to talk about papers written by some other folks. Builds on, I think, a body of work that is emerging in the United States. Catherine Wolfram is big in this literature as well, who's here. And I want to sort of give a sense of my view of how the energy efficiency economics literature is developing, or at least a summary with a particular focus on a couple of things that I've worked on, just because I know that stuff better. So just to kick this off, this is a figure displaying the total investment in energy efficiency over an 8-year period between 2009 and 2016 in the United States. And in fact, all of this, all the data that I'll show you are from the United States, but you'll see that the economics are just economics. So I hope that it will be useful for people who don't necessarily focus on the United States. What these data show, so $408 billion of investments made in energy efficiency over this 8-year period, about $70 billion spent on demand-side management programs. So these are electric and natural gas utilities that are running programs for their customers. Fuel economy standards, estimated cost is over $100 billion, about $125 billion for fuel economy standards that were implemented or promulgated in these years. Actually, the biggest category of cost is energy conservation regulations that most of us have never heard of. Things like industrial boilers efficiency regulation or commercial refrigerators, and these add up to about $200 billion, and the stimulus was a small part as well. Why do I say investments? It's because actually almost every single one of these dollars went through a bureaucratic cost-benefit analysis process where some group of people said there are going to be more benefits than costs. So $408 billion in costs and much more than that actually in projected benefits according to the analyses. And so this is for me, I think, the jumping off point that this is a big deal. Why are we doing this? I think this quote sums it up there are lots of quotes that you could use, but this quote I think sums it up for me the best. Energy efficiency is recognized as the lowest cost, most abundant, and cleanest source of energy, offering a win-win solution for economically and environmentally sustainable growth. So what do they mean by win-win? They mean two things. We're going to reduce externalities associated with energy use, and we are also going to save consumers money. And so what I want to do in this talk is formalize a little bit, just briefly formalize this in a simple model that I'll use throughout the talk. And then I want to talk about what the recent empirical research is saying about this argument. And then I'll dive into two quick case studies. One on a large residential retrofit program called the Better Buildings Neighborhood Program, and the second on a company called O-Power that does what you might call behavior-based conservation, or providing people with information about conservation norms. So this is the lineup for the talk. So question one, what was the economic argument for energy efficiency regulation? And I just want to write this down so I can refer back to it in a couple different places. It's not going to be very complicated. The idea is that there are individuals who are heterogeneous who have a distribution of possible investments that they could make. And this equation is an equation saying that there are some investments with social benefits larger than social cost. This is like the motivation for the policymaker to get involved. And so if I were to sum up the social benefits and social costs, there are a bunch of people who have investments that reduce energy use, so there's some energy savings in this first category here. And then there's we're reducing energy use, which also reduces energy use externalities. And I'm going to sum those over time. So this is the present value of energy savings and externality reduction. There's also going to be some non-monetary, non-financial net benefit that we want to start to think about that's going to play a key role in a couple of the papers that I'll talk about today. So I've called that C sub I. So that's like if you get your house weatherized and you put insulation in your walls, that's the hassle of having a bunch of contractors traipse through your house, pull your walls out in some cases, or at a minimum cut a hole in your wall, blow insulation in there. You got to clean up after them. That's sort of stuff, and there are many examples of this. Some of these are costs, some of these are benefits. But this non-monetary thing is what I'm calling CI. And then the idea is that these benefits are larger than, as I've written this equation, they're larger than the cost of making some investment. So, great. So despite the fact that this investment I has a social return, the problem, or the thing that we're trying to get across with this notion of a win-win argument, is that when individuals think about what are my private benefits, they don't adopt these investments because they perceive that the private benefit is less than the private cost. So the top one is the social planner's equation that he cares about, and the bottom one is the individual company or homeowner who's making a decision about whether or not to invest. And so there are two wedges that we want to start talking about between these two equations. One is this gamma I, this non-externality market failure that I've circled. And this could be a behavioral economics market failure, like I misperceived the savings, or it could be a more standard imperfect information sort of market failure, like I'm looking at a bunch of apartments that I could rent, and I don't perfectly observe that this one's really energy efficient and this one's not. So that I'm lumping all into one term I'll call gamma I. And the second is that, of course, the individual isn't thinking about climate change when he decides whether or not to be energy efficient. So these are the two market failures. And then if you go back to Diamond 1973, or before that you go back to Pigou, you can write out the social welfare function and then take the derivative. And from there, you've got the notion that there's a scope for government intervention in this market to correct these two market failures. Okay. In pictures, what is this argument? It's that the world's burning up and we're running out of money, and energy efficiency can help solve both of those problems. So now I want to focus on the running out of money or saving consumers money part of this, just for a moment, just to reintroduce an idea that I think many of you have thought about which is the energy efficiency gap. So this is the famous McKinsey energy efficiency cost curve. And what they're doing is they're taking a set of investments in this figure in the United States economy, and they're saying, well, on the far left, replacing computers, or replacing your home air conditioning, or improving air sealing in your house further over. And they're taking the amortized cost of doing this thing per unit of energy saved, and they're stacking up a cost curve. And you can compare this to the dotted line, the horizontal dotted line, which is the energy price. And the point is that all of these investments lie below the energy price, and so there's this huge area of net private benefits, unadopted investments that have positive net private benefits. So there are two, now I'm going to start to say something new. So there are two schools of thought on where these come from. And in the context of the equations that I wrote down, the standard school of thought comes back to this non-externality market failure. It's that there are firms that don't know that if they installed that energy efficient boiler, or homeowners that don't know that if they just put in that insulation, they could save all this money. And other classes of market failures as well. So that's argument one, and I think that's sort of your first reaction if you buy the data that underlie this figure. The second reaction, which I also want to think about today, is what I've circled in blue. It's actually the notion that the accountant who is doing these analyses is doing the accounting wrong. In other words, that the energy savings numbers that went into that cost curve are overstated or maybe understated, but they're misstated. And the second is that they are not properly accounting for these non-monetary benefits, which often, in a very natural sense, become unobserved. If I'm evaluating an insulation program, it's very easy for me to see and account for the fact that a homeowner spent $300 installing insulation. It's much harder for me to see and account for the 3.24 hours that the homeowner spent cleaning up after the contractors when they came in the house and putting a monetary value on that. So these are the two schools of thought that I think are really at odds in the policy discussion around energy efficiency these days. There's a set of people who think that the McKinsey cost curves and the unadopted net private benefits are explained by market failures that prevent individual firms and businesses from taking up those investments. And there are another set of people that believe that this is because McKinsey or whoever's doing the accounting has done the accounting wrong. And so what I want to do then is to provide some additional evidence from recent literature on how this argument's playing out. Unsurprisingly, there are most of the energy efficiency advocates are in this first camp. They're focused on, or the bottom camp here, they're focused on the idea that there are market failures that can be prevented. A lot of the engineers in the energy efficiency policy space are really focused, again, on this same argument. And some of the economists in this space, I think, are focused on the idea that the accountants have gotten this wrong. So I'll give you two examples of how this is playing out in actual evaluations. The first is from a paper by Meredith Fowley, Michael Greenstone, and Catherine Wolfram. This is they have two papers that came out of this project. This is a shorter paper that came out in 2015 that's arguing the following. They're saying, they were evaluating the Weatherization Assistance Program in the United States. So this is a program that gives free weatherization to low-income households. So they come to you experimentally. The authors came to low-income households and said, hey, here's a great program where you can save thousands of dollars in energy costs over the next 15 years, and you don't have to pay anything for it because the government's going to cover it. They contacted 60% of people in the treatment group. Only 15% of those people applied, that's the middle bar, and of those, only 5% of people actually weatherized their homes. And so one natural interpretation of this is just that there are large non-monetary costs, that C variable that I wrote before, that people are discovering as they learn more about this process. And it's those large non-monetary costs that are explaining why, even though you contact people and tell people what a great investment they have at hand, they're still not doing it. So that's one interpretation. Here is an example of, I think, how the alternative interpretation has gone. So this is from a summary put together by one of the national labs, which is part of the Department of Energy in the United States. And what they're doing here is in this figure, they're summarizing thousands of official cost-benefit analyses that were done of demand-side management programs, these programs that are run by utilities to save their customers money. And so there are several different classes of programs. There's the first bar is all sectors, and then focusing on residential, commercial, and low income, which is mostly the Weatherization Assistance Program. And this is on the y-axis, the levelized cost of saved electricity. And so retail cost of electricity in the United States averages 10 cents per kilowatt hour, so we're way up here. Wholesale cost is a little bit lower, but still above a couple of these bars. And so the interpretation that the authors of this report place on their data is, listen, we're running all these programs. We are saving energy at a cost that is well below the actual retail or even wholesale cost of electricity. And so there must be some non-externality market that's keeping our customers from adopting this in the first place. So this is an example of how you can look at, even very similar data and draw a different conclusion. Now, let me similar data in different contexts and draw different conclusions, partially based on what the context tells you. So let me start to now explain why you might worry about these McKinsey curves that I showed you and this interpretation of these evaluations. I'm going to show you some of the assumptions that are baked into the evaluations that underlie these numbers, these very low cost, very highly cost-effective numbers. This is a table that Greenstone and I put together in a paper, but it's actually based on a survey done by the ACEEE, or the American Council for an Energy Efficient Economy. And it's what ACEEE had done was survey demand-side management programs and ask, how do you do these evaluations that I just showed you the results for? 30% of programs include non-monetary benefits or costs. So 70% of programs aren't even thinking about that huge category of costs. 97% of programs use simulation predictions of the energy savings. And I'll explain more about how that's actually done for those of you who are not deep into this space. But the point is that this 97% are not taking actual energy bills and seeing how much the energy bills of the treated households change relative to energy bills of untreated households. Instead, they've got a computer program that says, we think that this is right, and they're not checking that against the data. 97%. And in fact, 70% of that 97% are not even using simulation predictions that are relevant for their state. And why does that matter? Because weather varies a lot. So maybe you're adjusting this, maybe you're not, but a lot of states are saying, well, I'm Wisconsin, I'm going to take numbers from Minnesota or Illinois or somewhere else. 81%, just to further this argument, 81% are not retrospectively evaluating their programs. So these are, I think, causes for questions, and they motivate some of the empirical questions that have been asked in the economics literature for the last few years. So, question one, are the benefits and costs correctly calculated? So are the engineering models correctly predicting the energy savings? How large are these non-monetary benefits and costs? Second, how large are these non-externality market failures? Maybe they're big, maybe they're small, but let's actually try to measure them. And third is this question of heterogeneity. So I sort of skipped through the Diamond 1973 formula, but one of the points of that formula is that, or one of the things that falls out of that sort of analysis is that ideally you would target energy efficiency policy at the types of consumers that have the largest market failures. And so you would have one instrument for every market failure, right? And so you'd have personalized taxes, ideally, that are really large for people that have big market failures, and you don't tax the people that don't have any market failures at all. And we're going to ask, in a world given that many of our policies involve uniform subsidies for energy efficiency, $70 for putting in an energy efficient refrigerator, $1,000 for buying an electric vehicle. How well targeted are these policies that they appear to be at the market failures that motivate them? So these are the research questions that I'm going to talk about today, and I'll present some data on these questions that I hope you can see from this introduction, I think really get at the heart of the big picture energy efficiency policy debate. So, question part 2 is, what did the empirical research say? The engineering models correctly predict the energy savings. So I'm circling this part of the model, this part of the model that I've set up, thinking about the energy savings part. So what happens, and I'm going to use home energy audits as an example just to fix ideas. So in the left, these are pictures of several guys who are doing a home energy audit in some person's house. And they walk around with a bunch of equipment. So at the bottom right of this picture, this guy's got some equipment that helps him to see holes in the wall, basically. And at the left, they're doing what's called a blower door test, which is they cover up your window, they cover up your door, and they add pressure to your house, and they see how quickly that pressure comes out, and that tells you how leaky your house is. And if your house is really leaky, that's saying that as you try to heat it up in the winter, that heat's going to dissipate really quickly. So these are the sorts of tests they do, and then they're going to put it into a computer model, and from there, in a home energy audit sort of setting, they'll stack up a set of recommendations that are personalized to you and your house. And this is an example of one such set of recommendations that was given to a household where they say, listen, if you put in attic knee wall insulation, it'll cost you $225. They'll save you $63 a year. So this is the sort of context in which this is used. There are two. Yep. Oh, that's great. Thank you so much. There are two ways in which this is used. One is to help homeowners make better decisions, and in the business context, help businesses to make better decisions about what investments to make. The second is, as I was showing you a few slides ago, that these are, in 97% of cases, the numbers that go into the program evaluation of this. And so these computer models are super, super important. So how well do these computer models work? There are two papers recently that have been, actually there are lots of papers. There's one paper written by Fowley, Greenstone, and Wolfram, which I think raised a lot of awareness about this particular issue. I would show that, except there's a particular figure I want to show you that they don't happen to have in their paper that I do have in the paper that I worked on, which is subsequent to theirs. And what I want to show you is, what do these models predict? And in a diff and diff style framework, what do we actually get? So this, on the y-axis, these are energy cost savings. And on the x-axis, this is months after the home energy audit. And so what's happening is people are having audits at time 0. And then over the next 1, 2, 3, 4, 5, 6 months, they are calling contractors and saying, yes, I'd like to put in that insulation. I'd like to put that in. So the savings that were expected, simulated by the models, are in gray. 0 savings before the audit. And then the expected savings are down here. So about $150 energy cost reduction per audited household is what you'd expect. What do we actually see in the data? You see about $100 per year reduction. And this is highly, when you collapse all the months, this is highly statistically different, highly statistically lesser reduction than was predicted. So this is just an example of how you do this. Fowley, Greenstone, and Wolfram do this as well. And in fact, they have an important additional thing they do, actually a number of great things in their paper. One of them is that they do this as a randomized experiment, and another is that they have more data on a control group. But as I'll show you now, they get similar and, in fact, even more severe, disappointing results. So what I'm showing you here is a set of different papers that are recent, most of them, and the ratio of empirically estimated savings to the predicted savings. So our black line divided by our gray line, if that makes sense. So we're getting about 60%. So we're getting about 100 divided by 155, something like that. So Greenstone and I get about just under 60%. Fowley et al. Get 40%, Fowley, Greenstone, Wolfram, in a different context for a different program. Some other numbers that are recent, bottom line is these are all short of 100. And in fact, this one's from 1991. This problem people have been aware of this problem for a long time, and it's not getting fixed. And so what are the implications of this, by the way? We'll get to more of the implications in a bit, but at its core, what does this mean? It means that when the home energy audit programs are going to homeowners and saying you can save X dollars, they are misrepresenting that. The actual savings on average will be X times 0.6 or X times 0.5 or something like that. And Greenstone and I actually, in the paper that we are working on, tally up the welfare losses from that. And you can imagine doing a demand estimation where you give people the wrong information and then calibrate the investments that people made because they had the wrong information and the welfare losses from that. And in that framework, the welfare losses from this are huge. There's a second reason why this matters, which is that these are the numbers, are the simulation predictions are what's being taken to the program evaluation people, to the policymakers. And so every time you see a policy, a quote in a newspaper or a regulatory evaluation or the American Council for the Energy Efficient Economy saying we're going to save X dollars through energy efficiency, these evaluations suggest that the real number is we're going to save X times 0.6 in energy efficiency. So that's why this matters. So I was talking about the energy savings there. There is, now I want to focus on this other issue, which is consumers' non-monetary benefits. So this C term that I've circled in red. And so again, as I showed you before, the typical regulatory evaluation just zeroes that out. Says it's zero. No cost, no benefits. What are we missing? We're missing, well, I get warm glow because I'm saving the environment. We're missing my home is more comfortable because I have insulation. We're missing I'm using more energy services and keeping my home warmer, and that's a utility gain. We're missing the time and hassle, as I was talking about earlier, of having construction people in your house. We're missing, we'll talk later about O-Power and social comparisons. We're missing that you might be inspired or guilted by learning that you're better or worse than your neighbors in some context. So what does that add up to? I'm going to give you a figure that shows that these are very large. I'm going to have to do an introductory figure first. So this is from this paper, the same paper with Greenstone, where we have data in this figure from home energy audits of about 1,300 or 1,400 people. And each of those people was recommended, 2, 3, 4, 5 different things they could do. Insulate your house, get new windows, put in a new heating system. For each of those investments, you can say, what's the post-subsidy cost, the price, thus the cost the homeowner would pay for taking it up? And how much would you save at retail energy prices? And from that, construct a net private monetary benefit. And this is just the distribution of investments. So these are great investments that were proposed to homeowners. These are loser investments that were proposed, financial loser investments that were proposed to homeowners. First thing, there's a lot in the negative category, by the way. So in this program, we were actually very surprised. There are a lot of investments that don't make any sense from a financial perspective, even after the subsidies and even at retail energy prices that are above wholesale acquisition costs. But the point I wanted to make with this is to think about what does this say about unobserved or non-monetary costs and benefits? So how would we see this? Well, if people acted only based on the financial costs and benefits, nobody would take up any of this. These are all financial losers, and if there's no non-financial costs and benefits, nobody would take up any of this. And everybody would take up this. So I'm going to plot now the take-up rate of these investments for each min of this histogram. And that's on this axis. So the take-up rate, 0 here, 70% at the top of this. And so what do we see? We see that 30% of people are taking up super loser investments. And we see that only 70% of people are taking up super winner investments. So what does this say? It means that people perceive a very wide dispersion of non-monetary benefits and costs that are rationalizing these take-up decisions at the same time. And so for evaluations to ignore these is super risky, because it could be that the mean of these things is actually really high, it could be that it's really low. There's just a really wide dispersion in these costs. They matter a lot. Okay. Next research question that I set up. So I've showed you that the energy savings might be mistaken. I showed you these non-monetary costs matter. Now I'm going to come at this from another perspective. And I'm going to ask, remember the Mckinsey curves, for those to be real, it must be that there is some market failure that's keeping people from taking up these investments. So the first two things I showed you were, let's attack the McKinsey curves and see if their assumptions are right. Now I'm going to come at this from another perspective, and I'm going to say, well, if they're right, it must be that we're going to be able to measure market failures that rationalize this. So let's try to do that here. So examples of relevant market failures. I think these are sort of standard, but you're buying or renting a energy-using durable, and you have imperfect information about the attributes of your choice set. There are behavioral biases. There are credit constraints. And something that I've been working on is trying to focus in on measuring the behavioral biases that might or might not explain under adoption. And I'll give you one example of a paper that I'm currently working on with Chris Knittel from MIT that gets into this issue. And it's the idea that, well, if people are imperfectly it's just a very simple, almost literalist argument. It's the idea that if people aren't paying attention or they're not well informed about energy costs, that you could inform them and see how their choices change. So in other words, I'm going to have an intervention where I have a set of people, in the case of the paper with Chris Knittel, there's a set of people that are shopping for cars, and there's going to be an informational intervention where a guy's going to get in their face and say, hey, do you know about the fuel costs and the fuel economy ratings of these different cars you're looking at? Now, we didn't hire that guy. We wanted a little bit more credibility. So we hired a guy who looks like this. And that guy is only going to talk to half the population. There's going to be a treatment group where that guy says, hey, here are the cars that you're looking at, and here are the fuel economy ratings of these cars. And if you get this one, you're going to spend $1,000 a year on fuel costs, given what you just told me are your driving patterns. If you get this other one, you're going to spend $1,200 a year. So think about that. And a control group's not going to get that. And the control group woman is very confused. You can see at the bottom right, she has no idea the hypothesis is she has no idea what's going on. And so again, the idea is that if the treatment group buys cars that have higher fuel economy ratings than the control group, that suggests that the information problem that exists in the control group is systematically affecting people's purchases and making them less energy efficient. So this sort of idea would explain these McKinsey curve unadopted privately profitable energy efficiency investments. So I'm going to skip another paper that does something like this. So in the paper with Chris, we went to car dealerships. We actually developed an iPad intervention. This is a little hard to see, but here I think this is actually from a movie, and if any of you know what movie this is from, please tell me afterwards. But these are two people in a dealership looking at an iPad. In fact, so we, with Ford, developed this informational presentation as part of an iPad, and we hired people to deliver this to people at these dealerships. And so what this does is it says, well, here's the car that you have now. I know that these were made up numbers for the purpose of developing this figure because this person drives a Ford Crown Victoria, which is not a car that anyone drives anymore. But in any event, that's the current car that this person had. And this person had told us, I think the price of gas is going to be $3. I drive 5,000 or 10,000 miles a year, and 62% of my driving is on the highway, 38% is on city roads, and so we're actually able to highly personalize this fuel cost information for the vehicles that you're considering most closely. And so this person in this figure had told us, I'm looking at the Ford Fiesta, the Ford Taurus, and the Ford Edge. And we say, this is how much fuel is going to cost you. And there's actually several more pages to this intervention where we go through different ways of drawing attention to fuel costs and giving people information. So what do we find? Long story short, zero. Absolutely nothing. It's a statistical zero in the sense that we see no statistically significant impacts of this information on the fuel economy of cars that people buy. It's also an economic zero in various senses. It's just we can rule out any number that would be meaningfully large. So there's basically information, or at least the information that we provided has no impact on the fuel economy of vehicles that people purchase. So what does this mean back in this framework that I've tried to set up? It's the idea that maybe the treatment group and the control group were not actually that different in terms of their information. The information that the control group doesn't have and the treatment group does is not systematically affecting the energy efficiency of these products that people are buying. So this is one way of doing this. This sort of market failure measurement is very difficult. The key problem with this is, what do you think we did in our intervention? Maybe our intervention wasn't very well designed. Maybe it was a great intervention, which I actually think it was. Maybe it was a great intervention, but people forgot it. So you were paying attention for 5 minutes, great, and then you forget the information and you buy a car a month later. So this is, in this context, the challenge that you have in trying to measure the systematic effect of this information market failure. If you were trying to measure any of these other market failures, and there are great papers that try to do that, you run into other problems like this. So this is one of the challenges. So I want to summarize what I've just shown you here. And I actually think that these several papers that I've shown you are slightly more representative of a broader set of papers that people have been working on in the last 5 or so years. I think it's safe to say that the recent evidence in the economics literature broadly is countering this energy efficiency gap argument. And in particular, that we're finding in several different papers that the energy savings are not what was expected. The non-monetary net benefits can be huge and need to be counted. And these non-externality market failures are small in a set of papers, where by small I mean small in a sense that they're not large enough to justify the types of policies that have been implemented supposedly to address these non-financial market failures. So that is how I would summarize this literature, including work by Catherine, who's here, some work that I've done and work that many other people in the space have done. Now, that may be the wrong summary. So Danny Kahneman talks about doing pre-mortems. Have you guys seen this? So he talks about a business makes a decision or almost makes a decision, and before they finalize it, they take a few minutes to imagine the scenario in which they were wrong and try to think through why it was they were wrong. And then they do that to improve the quality of the final decision that they might be about to make. If this conclusion is wrong, I can think of 3 reasons why it might be wrong, and you guys could probably come up with 10 more, but here are my first 3. One is it's hard to measure a market failure. So if you focus your efforts on this third area of research that I've talked about most recently, I highlighted in the case of this paper with Chris Knittel that we are doing our best, but it's hard to definitively measure what the effect of this informational market failure is. The second thing is a little more subtle, but I think probably more important, which is it's especially hard to measure all market failures. So what you can conclude from the auto information provision experiment is that the set of informational and lack of attention style biases that our intervention affected are not systematically important in the US market or in the samples that we used. Well, okay, well, what are the set of informational and intentional market failures that we tested? And maybe the real market failure is something else that our intervention doesn't affect. Some other papers, rule out. Some other recent papers by Erica Myers, for example, talk about residential energy efficiency investments, and they seem to sort of rule out various classes of market failures that might have existed there. What if there's another class of market failures that is not in these papers? I think a third thing that is worth thinking about is what I would call groupthink among economists, because I think many people in this space, I definitely don't speak for everyone, but I think that there are a number of people that would say that they agree with this conclusion that I'm drawing. And I don't think we have enough opposition in the energy efficiency economics space. So I think if we're wrong, it's because one possible reason could be groupthink. There are probably 10 other reasons, and I'm excited to talk about this more with you afterwards. Catherine Wolfram is here, probably has 10 other reasons as well. Okay, so that covers part of the recent research. I want to talk about another class of research question that I introduced earlier. And it's this question of targeting. And again, the idea is that there's a distribution of market failures in the world. Some people are well-informed, some people are poorly informed. Some renters, when they look at homes, are well-informed about the energy efficiency of those homes, some are not. And so ideally, you would have policies that target the big market failures where they are and don't distort the decisions by the set of agents that don't have large market failures. And so I've highlighted the two market failures that we're concerned about. Again, it's externalities and a broad class of non-externality market failures. I want to talk briefly about targeting of policies. And in particular, I'm going to lay out, here are the types of market failures that exist, and I'm going to ask how well targeted do policies that we have appear to be at people with large market failures, at places with large market failures, and as policy instruments. And what I'm going to do is I'm going to take a set of policies and I'm going to compare them to these market failures in a sense that'll become clear in a sec. So let's talk about people. So people might not adopt privately profitable energy efficiency investments because of credit constraints, because of imperfect information, or because of behavioral biases. Maybe there are one or two others, but here are three big ones. The types of people who will be affected by these market failures, well, people who are less wealthy are more likely to be credit constrained. People who are landlords and renters are more likely to be affected by what people in the space call the landlord-tenant market failure, asymmetric information about the energy characteristics of a home. And people who are not environmentalists, and this is a little more subtle, but the basic idea is just if you're an environmentalist, that's a signal that you're probably thinking about energy and energy efficiency a little bit more. And so what I want to do is look at energy efficiency subsidies in the United States and ask, are these subsidies targeting these type of people where the market failures are largest? We'll look at two programs. The first is federal residential energy credits. This is from a paper by Borenstein and Davis, Severin Borenstein and Lucas Davis. And what they're showing here is, so this is the, using tax data in the United States, the average energy efficiency credit claimed by individual filers
on the y-axis. So these people claimed $20 of energy efficiency, any residential energy credits equal $40, as a function of their adjusted gross income. In other words, how rich they are. And so what do you see? Nicely upward sloping. So energy efficiency is for the rich, is basically the summary of this graph. There are two problems with this. One is that it's not well targeted at the credit constraint market, at the possible credit constraint market failure. And the second is that it's regressive. So here are two problems with this. You can do this. I also got data from an energy efficiency program that is anonymous, but it's a very well-regarded energy efficiency program in the United States. Program participation rate on the y-axis and income on the x-axis. So this is the same notion as the graph, the Bornstein-Davis graph that I just showed you. Nicely upward sloping. So again, energy efficiency in this particular program is for the rich. This is take-up rates for owner-occupied properties and rental properties. So energy efficiency is not well targeted at the landlord-tenant information asymmetry. And finally, energy efficiency is for environmentalists. We have a sort of a weak measure of this, but there are programs which in the US we call green pricing programs. For those of you who don't know what these are, this is you pay more money to get renewably generated electricity. So these guys who are participants are more environmentalists. They think more about energy efficiency. They're probably better informed. These guys are non-environmentalists. They're probably worse informed. If these programs were well targeted, you'd want the non-environmentalist, possibly poorly informed guys to be taking this up more. That's not what you see. You see a higher take-up rate by the green pricing participants. So these are three examples from a particular program, plus the Bornstein-Davis example from another program, that suggests that this type of energy efficiency programs that we're looking at are not well targeted at the market failures that motivate them in the first place. So there are this is sort of a very informal analysis, and I think this could be done way better with better data and a more precise definition of what targeting is. But this is a suggestion that I'll leave out there for people. I'll do the same thing for places. So same market failures, and I'm going to add mispriced energy as another market failure. In other words, the idea that one reason to have energy efficiency programs is that there is an unpriced externality, and you're not politically or for some other reason, you're not able to actually price that into energy costs. So another reason to have an energy efficiency program would be if you could put it in the areas that have energy that's particularly underpriced relative to social marginal costs. So areas that get a lot of their power from coal plants, for example, and also have low energy prices. We'd like energy efficiency to be placed in the areas of the US where you see these market failures. What are the places that are most affected? Well, it's probably the poorer parts of the United States as before, the places where there are less environmentalists, and the places where energy prices are too low. Let me show you some maps. I love maps. Here are the wealthy parts of the US. So what are the wealthy parts? Upper Northeast, West Coast, some in the upper Midwest there. Definitely not the South. Environmentalism. What are the environmentalist parts of the US? So this is measured by how many people are buying hybrid cars. Chris Knittel gave me these data. Share of vehicle registrations that are hybrids. Where are people environmentalists by this measure? West Coast, a little bit in the upper Midwest, Northeast. You're getting the picture here as well. Where is retail electricity priced too low or too high? This is an early figure from Borenstein and Bushnell. Bushnell and Seven Borenstein have some estimates of the parts of the country. They estimate the environmental damage imposed by power generation that is sold in a particular state, and they compare that to the residential electricity price that's charged. So green areas are prices where the price is too high. For those of you who know about California, the marginal retail price in California is super high, and the grid is super clean. So electricity prices by their notion are actually above and well above social marginal cost in California. Where are electricity prices too low? Here. Coal power comes here. Also another part, Upper Rockies. So if you could target energy efficiency programs, you definitely wouldn't want them here. And in fact, if this was the only market failure, you would want an energy inefficiency program to offset this market failure. And you'd want energy efficiency programs here in Appalachia. So I've shown you maps of where we'd like to have energy efficiency. Where do we actually spend money on energy efficiency in the US? Upper Northeast, West Coast, Upper Midwest, definitely not the South. So this is saying that energy efficiency spending is in exactly the wrong places to offset the types of market failures that motivate it in the first place. You can do this in figures. Just in case you can't do regressions from graphs, I'll show you the figures. Basically, the point is that the point I've made on the graphs is correct. Energy efficiency is in all the wrong places. This is not a statistical accident. It's not, there's no central planner that's putting energy efficiency dollars in the wrong place, so it's not an intentional thing. It's something that's occurring in equilibrium based on the policies that we have in the US. But this equilibrium is also not an accident. The types of places that are rich and environmentalists are the places that don't need energy efficiency by these measures that I've set up. The places that are rich and environmentalists are the places that support energy efficiency policy. So that's why I think this is arising. And so then the question is, if you were making policy, does this targeting issue also exist in other countries? At least in the US, you might ask, how can we target energy efficiency dollars and advocacy less at places like California and more at places like Alabama, which is one of these lower income, less environmentalist states. So that's the targeting issue. So in my last 10 minutes, what I want to do is give two quick case studies. I'm skipping a couple things. Two quick case studies of all of these issues from recent papers that I happen to have worked on. And the first case study is actually going to be the same paper with Michael Greenstone on residential retrofit. So what we were doing in this paper, I told you this is a home audit program. It's in Wisconsin. It's part of something called the Better Buildings Neighborhood Program. And there are 100,000 households in our broader sample. And we tried to encourage them to get home energy efficiency audits. 1,400 of them actually got audits, and of them, like 800 actually moved forward with some investment. And so what I want to do is show you one small part of that evaluation and how it played out in the media. What we're going to do here is we're going to count up energy savings and externality reduction. I'm actually going to forget about, for these slides, not in the paper, but for these slides, I'm just going to forget about this term. And so what I want to do is say, what are the financial net benefits of this, the social financial net benefits? So counting up energy savings, dollarizing the externality reduction, compare it to the costs, and just show you how that plays out in this case. As I said, this was a Better Buildings Neighborhood Program. It's about $500 million of federal investment that went into this. 120,000 homes upgraded, $878 million in costs, and supposedly $850 million in lifetime energy cost savings. And actually, before you get anywhere, you can say, oh, there seems to be more costs than benefits, even in the program's official evaluation. So what did we find? Long story short, I'm not going to show you this whole table, although I think it would be a lot of fun. The thing I want you to focus on is we're evaluating, I'm going to show you the internal rates of return down here. So we got energy savings that are coming in over a 20-year period, and we've got upfront costs. I'm going to tell you the IRR for these investments in the programs. The first two are just the programs in Wisconsin that we looked at. And there's a 4% internal rate of return at the simulation predictions of energy use. Once you adjust that for the fact that we only had what did I show you earlier, a 58% empirical realization of their simulated savings, the internal rate of return is negative 4.1%. Fowley, Greenstone, Wolfram have a table that's like this. Their IRRs are also bad, and they also move a lot when you adjust for the actual realization rate. This is for the national programs. So you might say, listen, how did you end up working with these Wisconsin programs? Maybe you were just working with the bad eggs of the bunch. Could have happened for some systematic reason, could have happened just idiosyncratically that these guys in Wisconsin are terrible. So we can actually do this part of our paper for the full program. It turns out that we're working with the good apples of the bunch. So for the full program, the IRR is 1.5% when you use the simulation predictions. And when you adjust for the less than 100% realization rate in those programs, actually as measured by the federal government's own evaluation, you get a minus 5% IRR. So that's how this played out. Now just how did this go in the media? There was actually not too much media coverage of this at all, but that there was, I thought was very interesting. So the response from the Alliance to Save Energy was that the federal government did a much more comprehensive and peer-reviewed report, so ours is not in a journal yet, it's just an MBR paper. Peer-reviewed report finding that every dollar spent yielded $1.76 in bill savings. So you're getting more savings than dollars spent. And $5.2 billion in total savings. And so basically what the Alliance to Save Energy is saying is these guys haven't gotten their thing peer-reviewed, and perhaps more importantly, they're just wrong. They've got this wrong. And indeed, what she said is straight out of the Department of Energy website. These are the numbers. What she said is exactly right. Except dollars spent is subsidy outlay by the federal government. And every dollar of federal outlays also went with considerably more than a dollar of private spending to actually pay for the investments that were made. So the dollar spent thing is not even the right class of things. That's the transfer that was made. What we really want to know, or what we're focused on in our benefit cost analysis, is the actual physical investment cost. The bill savings that are in this evaluation that is being promoted is the bill savings that projected the simulation predictions at retail prices. And retail prices are marked up again relative to the wholesale marginal cost. So it's just the wrong numbers. Right? It's easy to pick on advocates, and it's easy to pick on advocates that aren't in the room to respond, so I don't mean to do that too much. But I think my interpretation of this is that there are a lot of numbers out there, and some of the numbers that I see in the policy discussions are probably not the right numbers to be thinking about. Okay, case study number 2 is home energy reports. I've done a couple of papers on these, and this is, I promise, my last paper on these because I'm a little tired of it. But what home energy reports do is, there's a company called O-Power, which is one of the many companies that do this, but also the largest company that does it. They partner with utilities, and in fact, they've partnered with utilities all across the United States and all across the world, including the UK and France, to get people's energy use data, get their neighbors' energy use data, and do a bunch of randomized experiments where they send a treatment group information on how your energy use compares to your neighbor and whether that's a good thing or a bad thing. And so what's missing in all of these evaluations is the following thing: the non-monetary net benefit that goes to consumers. So just in brief, what happens when these are getting evaluated in the official regulatory space? The regulators are saying, we ran a randomized experiment, we know how much energy was saved, let's add the value of that energy saved, and let's compare it to the implementation cost of the program. What's missing from that is everything that consumers did to actually generate that savings on their end. And so the assumption that's being made in the official evaluations of this program is that if I send Catherine Wolfram a home energy report, she's able to somehow magically costlessly reduce energy use in response to that. What does this miss the financial costs of buying new insulation or whatever you did to save that energy, time costs to actually make that happen, changes in comfort. I'm living in the dark, I'm living in the cold because I'm adjusting my thermostat or turning off my lights all the time. And I might like or dislike these things. Some of these could be positive, absolutely. I might like or dislike being sent these things. So what we did, and this is tricky, right? The reason the regulators are leaving this out is that it's super hard to quantify this. It's really easy for me to do a randomized experiment, give half the people home energy reports and see how much energy is saved. It's very hard to actually, in some rigorous way, figure out how much, what you're actually doing to generate those savings and how to dollarize them. So that's why this is a challenge. That's why this is happening. But you might also expect that this is a systematic bias in a particular direction, right? Because I'm assuming that somehow this energy savings that we are observing in response to sending people social comparison letters is being generated completely costlessly. And you can imagine that there's probably some cost that's going in, some consumer cost and time that's going in. So that, I'll spare you the details of this paper. This is with Judd Kessler, but the way that we try to quantify this is to sell people home energy reports. And their willingness to pay is then a reflection of the all-in net consumer benefit. And we take that and we put that into a cost-benefit evaluation. And our conclusion is that the net benefits of these programs are overstated by about a factor of 2. So this is a huge energy efficiency program of a class of programs, behavior-based programs that lots of people care about. This is like the poster child of this. And it's a great program. It's run by great people. It's a fantastic company. And the regulators are overstating the welfare gains from this enterprise by about a factor of 2, as far as, per our calculation. So to conclude, the core question I was asking is what explains energy efficiency, this energy efficiency gap? And I set up 2 ways of thinking about this. One is that it's indeed non-externality market failures, and the other is that the accountants are overstating the net benefits. And I think one of the things that I'm starting to believe is that some of the recent economics research points to more of the latter, more of misaccounting, and less of the former, less market failures. Furthermore, I showed you that at least for the policies that I looked at in those maps and figures, some of these existing policies appear poorly targeted to address the non-externality market failures that do exist. And finally, in my 2 case studies, I showed you that standard evaluation approaches may overstate the net benefits, at least for the 2 classes of programs that we looked at today, residential retrofits and behavior-based conservation. So these are my conclusions. I'm excited. I think I've ended right on time, and we have time, maybe 5 to 10 minutes for questions and comments, and I really appreciate being able to be here today.